We need to differentiate cosine inverse of x minus x raised to the power of negative 1 divided by x plus x raised to the power of negative 1 with respect to x. We will begin by considering y to be equals to our given function, which is cosine inverse of x minus x raised to the power of negative 1 divided by x plus x raised to the power of negative 1. We'll multiply x to the numerator and the denominator. We'll make it cosine inverse of x squared minus 1 divided by x squared plus 1. What we can do, we can take negative as the common factor from the numerator, which makes it negative times 1 minus x squared, and we can rewrite the denominator as 1 plus x squared. Now we can apply a property of inverse trigonometric function. That means if we have cosine inverse of x negative x, that becomes equals to pi minus cosine inverse of x. That means we have pi minus cosine inverse of 1 minus x squared divided by 1 plus x squared. So this is y. Now what we'll do, we'll try to simplify the expression on the right hand side by making a trigonometric substitution. So here we are going to consider, let's say, x equals to tangent of theta. So when you put x equals to tangent of theta, then 1 minus x squared divided by 1 plus x squared will become 1 minus tangent squared theta divided by 1 plus tangent squared theta. Now 1 plus tangent squared theta, that's a trig identity which is given by secant squared theta. That means in place of 1 plus tangent squared theta, we can have secant squared theta. Fine. Now what we'll do, we'll divide each of the terms in the numerator with secant squared theta. So we're 1 over secant squared theta minus tangent squared theta divided by secant squared theta. The 1 over secant squared theta, that gives us the cosine function, where cosine squared theta minus tangent squared theta divided by secant squared theta, that's us sine squared theta. Cosine squared theta minus sine squared theta is another trig identity, which is cosine of 2 theta. So that means we can rewrite our expression for y as pi minus cosine inverse of, in place of 1 minus x squared over 1 plus x squared, we can replace it with cosine of 2 theta. Now cosine inverse of cosine of 2 theta makes it 2 theta, which gives us y equals to pi minus 2 theta. Now since we consider x to be equals to tangent of theta, that would mean that theta must be equals to tangent inverse of x, such that our expression now becomes y equals to pi minus 2 times tangent inverse of x. Now we'll take the derivative on both sides with respect to x. So we have di over dx equals to dy over dx of pi minus 2 times d or dx of tangent inverse of x. So pi is a constant, so its derivative will be 0. So we will have derivative of the inverse tangent function, which is 1 over 1 plus x squared, and this will give us negative 2 divided by 1 plus x squared. Hence derivative of cosine inverse of x minus x raised to the power of negative 1 divided by x plus x raised to the power of negative 1 with respect to x, that will give us the value negative 2 divided by 1 plus x squared. Let's move on to the next problem. So we have to differentiate the given secant inverse function. So let's begin by considering y to be equals to secant inverse of x plus x inverse divided by x minus x inverse. So we'll multiply the numerator and denominator of the rational function x plus x inverse over x minus x inverse with x, which will make it secant inverse of x squared plus 1 divided by x squared minus 1. Now we can take negative as the common factor from the denominator, which will make it negative multiplied to, we can rewrite the numerator as 1 plus x squared divided by 1 minus x squared. So here we can use the property of inverse trig. That means whenever we have secant inverse of negative x, that becomes equals to pi minus secant inverse of x. Right? That means function will become pi minus secant inverse of 1 plus x squared divided by 1 minus x squared. We can further simplify this. Let's label this as number 1. We can further simplify as number 1 by taking x to be equals to tangent of theta. So we've already performed this. Instead, we have 1 plus x squared. Earlier it was 1 minus x squared divided by 1 plus x squared. So this time we have 1 plus x squared divided by 1 minus x squared, which will be equals to, we'll have secant squared theta divided by 1 minus tangent squared theta. So what we'll do, we'll divide both the numerator and the denominator with secant squared theta. So that means this will be cosine squared theta minus sine squared theta. And cosine squared theta minus sine squared theta is cosine of 2 theta, which makes it equals to secant of 2 theta. So that means R1 will become y equals to pi minus secant inverse of secant of 2 theta, which will make it y equals to pi minus 2 theta. And since x equals to tangent of theta, that implies theta must be equals to tangent inverse of x, thereby making y equals to pi minus 2 times tangent inverse of x. Now we can take the derivative on both sides with respect to x. The derivative of pi will be 0, and derivative of the inverse tangent function is 1 over x squared. So we have negative 2 divided by 1 plus x squared. Hence, derivative of secant inverse of x plus x inverse divided by x minus x inverse with respect to x will be equals to negative 2 divided by 1 plus x squared. Right. Let's move on to the next problem. We'll have to find the derivative of sine inverse of 1 minus x squared divided by 1 plus x squared. So let's begin by considering y to be equals to the inverse sine of 1 minus x squared divided by 1 plus x squared. So here we will make a trigonometric transformation. Here we will consider x to be equals to tangent of theta, such that 1 minus x squared divided by 1 plus x squared, that becomes equals to 1 minus tangent squared theta divided by 1 plus tangent squared theta. And we have already done this. This is equivalent to cosine of 2 theta. So that means y will be equals to sine inverse of cosine of 2 theta. However, we need a sine here instead of a cosine. To do that, we're going to use the fact that cosine of theta is given by sine of pi over 2 minus theta. Since we have cosine of 2 theta, in our case, we will have sine inverse of sine of pi over 2 minus 2 theta. Now you can get rid of the sine, which will give us pi over 2 minus 2 theta. Now consider x to be equals to tangent of theta, which means that theta must be equals to tangent inverse of x. Hence, our function y will now be equals to pi over 2 minus 2 times tangent inverse of x. So that means the simplified form of sine inverse of 1 minus x squared over 1 plus x squared will be pi over 2 minus 2 times tangent inverse of x when we make this transformation x equals to tangent of theta. Now we'll take the derivative on both sides with respect to x, which will be equals to derivative of pi over 2, which is a constant, will be 0, and derivative of negative 2 tan inverse x will be negative 2 over 1 plus x squared. So therefore, derivative of sine inverse of 1 minus x squared divided by 1 plus x squared with respect to x will be equals to negative 2 divided by 1 plus x squared. Now let's move on to the final problem. So here we need to find out the derivative of secant inverse of 1 over 2x minus 1. So let us consider y to be equals to secant inverse of 1 over 2x squared minus 1. We'll simplify the expression on the right hand side by taking x to be equals to cosine theta, such that our expression 1 over 2x squared minus 1 becomes 1 over 2 times cosine squared theta minus 1. Now we have an identity cosine of 2 theta, which is given by 2 times cosine squared theta minus 1. That means in the denominator we can replace it with 1 over cosine of 2 theta. The reciprocal of the cosine function is the secant function. So we have secant of 2 theta, such that equation number 1 will become y equals to secant inverse of secant of 2 theta, or simply 2 theta. Now, since we took x to be equals to cosine of theta, that would mean that theta must be equals to cosine inverse of x. Or we can simply say that y will be 2 times cosine inverse of x. Now, we finally take the derivative on both sides with respect to x. So, we have di over dx equals to 2 times derivative with respect to x of the inverse cosine function, which will be negative 2 divided by square root of 1 minus x squared. Therefore, the derivative of secant inverse of 1 over 2x squared minus 1 with respect to x will be equals to negative 2 divided by square root of 1 minus x squared.